Alrighty, folks. So today we're talking about section 6.3. And I'm going to be completely honest with folks. I really only split these last two sections into two videos for organizational purposes, right? So that you could look up for a given section each one. Normally, I would just include this on into 6.2, because really all it's saying is that with a calculator, you don't need to do the standard normal distribution, right? So this section is all about how normal CDF really wants your lower bound, so the smaller number, which is -1 e to the 99 if you don't have one. The upper number, your upper bound, which is 1 e to the 99 if you don't have one. And then you can put in mu and sigma. If you don't put in mu and sigma, it assumes that you want the standard normal deviation and a 0 and 1. So if no mu sigma, it assumes mu equals 0 and sigma equals 1, right? That's why all the commands we talked about last time worked. For the standard normal distribution, we just had this lower and upper. We didn't plug in the mu and sigma, so it assumed it was 0 and 1, and we got answers for the standard normal distribution, right? But if we have something that's not standard, then our calculator just handles it. So we'll do a problem for this one as well. Told y'all this was going to be really short because that's really all that happens in this section. So I'm going to pack a lot of questions into this one problem so I don't have to write a bunch of word problems here. Okay, so we got 4 questions here, right? We're saying that blood pressure in a particular population is found to be normally distributed, right? So we know we're dealing with a normal distribution, right? And we know that our mean is 113.8 and our standard deviation is 10.8. Right, so that's what our random variable is. That's what our distribution is. And this first question is asking what is the probability that the outcome we get at random is over 125. Right? And so we know we can plug it into our calculator because that's what this section's all about. It's normal CDF. And we want our lower bound. We don't have, or we do have one here, right? 125 is the lowest it's allowed to go. What we don't have is an upper bound. So we do positive 1 E99. I'm going to move this just a little to have some space. And then, because this isn't the standard normal distribution, we need to include the mean and the standard deviation. So we plug that into our calculator, and it gives us a value. Right? The second question, it's asking about a blood pressure under, so this is the same, someone's chosen at random, and we're wondering what's the probability that that person chosen at random has a blood pressure that's less than 115.5. So this is again asking a question about the normal distribution with a less than or greater than sign there. A lower bound, we don't have one of those. So we put negative 1e to the 99. And upper bound, we have there, that's that 115.5. Our mu is still 113.8. And our standard deviation is still 10.8. All right. Our next question is asking what's the probability that a person we chose at random is between 98 and 121. All right. And so that's going to be the normal CDF, because that's what all of these are. We have a lower bound, it's a 98. We have an upper bound, it's 121. And we have 113.8. We have mu and our standard deviation. Right? You should always have the smaller one of the first two, the smaller one goes first and the bigger one goes second, right? Because you want a lower bound and an upper bound. Right? So the last question is where we get a little bit tricky. Right? So this is asking the probability that x is less than 100 or x is greater than 130. Now there's two ways we can go about this, and either of them are fine. Right? One is to remember that if these two events are mutually exclusive, and I'm pretty sure that a single person can't have a blood pressure of less than 100 and greater than 130 at the same time. So they are mutually exclusive. We could write this as the probability that x is less than 100 plus the probability that x is greater than 130. And we could figure these out like we did up there, right? The same sort of idea. Or we could realize that this is the complement of it being between them, right? So we could do 1 minus the probability that x is in between 100 and 130, right? Because something is either less than 100, more than 130, or in between those two. So if our first event includes both the less than or the greater than, the opposite of that event is going to be being between them, right? So then we could do 1 minus normal CDF, 100, 130, 113.8, 10.8. Right. So both those ways would have been fine and should get us the exact same thing. So while we're doing these normal distributions, we do need to remember things that we learned in the probability section, right? Things like the complement rule, things like the mutually exclusive idea, our product rules and our sum rules. So those still apply even when we're talking about probabilities that come from distributions. All right. So we have one more section in this chapter about normal distribution, which is about going backwards. Right here, we've always started with x or z values and we figured out probabilities. but it turns out if we know probabilities, then we can find x and z values. And after that, we're going to move on to particular distributions that don't have names because of what they are, but where they come from. But that'll be for next week, so I will see y'all later.